Hello, 7th graders. Today we're going to be talking about the distributive property, and we're going to be simplifying algebraic expressions using the distributive property and then also using what we know about combining like terms. So a couple of things I want you to remember as we go through this. An algebraic expression is in simplest form when there are no parentheses, and no like terms. So when we have the distributive property, the problem will be set up. You'll see some like parentheses like this, and we have this number out in front of our parenthesis. So we have 2 times the quantity 3x plus 4. So right now this operation that's happening is multiplication. Another way to think of this is 2 groups of 3x plus 4. So I'm actually going to show 2 different ways to get our answer here, kind of like the longer way and then a shortcut. So 2 groups of 3x plus 4. I have 3x plus 4, I have another 3x plus 4, and if I combine the like terms from those 2 expressions, I have 6x plus 8. So I have no parentheses now, and I have no like terms. The 6x cannot be combined with the 8. The 8 is a constant. The 6x has a variable. So this would be my simplest form. The shortcut way to do it is we're distributing, or think of it as like passing out, the 2 to both of the terms inside the parentheses. And when I'm doing that, I'm using the operation of multiplication. So I'm distributing the 2 to the 3x, or giving out that 2 to the 3x. So 2 times 3x gives me 6x. 2 times the positive 4 gives me positive 8. And so I can end up with that same simplified algebraic expression. Over on this next example, I have 4, and then in parentheses, the quantity y minus 5. Couple of things to remember about this. When we have no coefficient on our variable, there's an invisible 1 as our coefficient. So that, that y is actually 1y. And so I have 4 groups of 1y minus 5. So if I look at this, I actually 1y, 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 1y is going to give me 4y. And then when I'm looking at these constants, I want to remember to look at that sign also. And so actually think of that as a negative 5. So negative 5 plus a negative 5 plus a negative 5 plus a negative 5 gives me negative 20. If I want to use the distributive property and multiply that 4 across both terms, all right, when we distribute, we're using the operation of multiplication. So I'm doing 4 times the 1y, and then 4 times negative 5. So 4 times 1y gives me 4y. 4 times negative 5 gives me negative 20. Because the 20 is negative, I can write that as subtraction. And so I would get 4y minus 20. I have no parentheses, I have no like terms, so it's in simplest form. Looking at this next one, we have 3 times negative 3m plus 5. I can distribute using multiplication, so 3 times negative 3m gives me negative 9m. 3 times positive 5 gives me positive 15. I get negative 9m plus 15. I have no parentheses, I have no like terms. This is my simplest form. This problem looks a little bit different here. We have the distributive property going on, but then we also have this minus 4. So that makes this problem a little bit different than what we've had so far. So what you want to keep in mind is that this minus 4 is kind of on its own right now. So the 3, when we distribute this 3, it only gets distributed to what's inside the parentheses. So when I distribute that 3 using multiplication, I'm multiplying only to what's inside the parentheses. So 3 times the q, or 3 times 1q, there's an invisible 1 as our coefficient. 3 times 1q gives me 3q, 3 times positive 1 gives me 3. So I've distributed the 3, I've cleared my parentheses. Now I still have this minus 4 back here. So now when I look at this expression, we're going to ask ourselves, do I have any parentheses? No, I've cleared those. Do I have any like terms? And the answer here is yes, we still have some like terms. So when I look, I have my 3q. There's nothing else to combine with that, so that'll stay the same. But then I have these constants. So I have positive 3 and a negative 4. Remember to include the plus and the minus as the sign on that term. So when I combine a positive 3 with a negative 4, I get negative 1. So I can write this as 3q minus 1. This is also similar. We have the distributive property going on, and then we have an extra term out behind it, the plus 7g. So to use the distributive property, the negative 2 is going to get distributed to only what's inside the parentheses, okay? So there's an invisible coefficient of positive 1 right now on that g. Negative 2 times 1g is going to be negative 2g. And then this is important to pay attention to this. Here I have negative 2 times, when I look at that 4, that subtraction sign makes that a negative 4. So remember, you're looking at that those subtraction signs as making that term negative. So a negative 2 times a negative 4 actually gives me a positive 8, so I can write that as plus 8. And then now I've distributed, I've cleared my parentheses, and I still have this plus 7g out here. So when we look, I have some like terms. I have negative 2g and positive 7g, which can combine to be 5g. And then I have my constant of positive 8, so I can write that as plus 8. On this example, we have the distributive property, but there's no number out in front of our parentheses. So similar to when we have a variable by itself and there's an invisible coefficient of 1, we also have an invisible 1 out here, okay? The difference here is this is a negative 1. So remember to think of that as negative 1 when you distribute. So I'm going to distribute a negative 1 through multiplication. So negative 1 times 4b gives me negative 4b. Negative 1 times positive 3 gives me negative 3. And I can write that, because that term is negative, I can write it as subtraction. I've cleared my parentheses. I have no like terms. That is in simple.